So hello everyone. Thank you for IoT London and Hardware Pioneer for having me here to share my research with you. So my name is Boyeun, a researcher at University of Exeter Business School. Today I'm going to talk about 3 approaches to IoT value creation. So here's a bit about me. So I'm originally from South Korea, have been working as a postdoctoral research fellow in DigitLab project since last year. DigitLab is EPSRC funded project that accelerates digital innovation for growth, impact, and transformation of large established organizations, but not necessarily. We're also working with SMEs. We are working on those 5 themes, but specifically I'm focusing on the last one, data-driven design, data-driven innovation. My background is I completed PhD in design at Lancaster University, which was a part of Petra's IoT project, which was also EPSRC funded research with 9 universities exploring issues around IoT, such as governance, security, privacy, acceptability and adoption, and also harnessing economic value. I did my master in design strategy and innovation at Brunel University, then worked as a service design researcher at South Korea, so my approach is very much service design. And as an academic career, I worked around I did research around how to use data for new product service development. So in relation to the DigitLab project and also my PhD research, this is what I'm going to talk about today. Firstly, I will talk about what is Internet of Things, then comparing creating value between things and Internet of Things, and introduce 3 approaches to IoT value creation, then 5 critical design principles in IoT development. So what is the IoT? I think you know better than me, so I'm not going to go through all the different definitions. However, there are some keywords that I'd like to highlight. IoT is interconnected objects, which minimize human interaction and allow for continuous value improvement. I know this is really important to achieve. Is any of you familiar with any of these development processes? Hands up. Which one can you tell? V-models. Some stage gate, some agile, yes. So these are the top 2 are the product development process, which illustrate that there is a gate between each phase to decide go or no go of product development. One on the bottom left is called V-model, and in the center is agile. Both are software development process. The one at the bottom is service development process, and the one next to it is product service system development. As you can see, the 2 columns separated product and service. Some of these are well known and still used by companies, but outdated, I would argue, because to explain Internet of Things development. Do you know why? Okay, because none of these encompass data process or encompass both hardware and software development together. These can explain the traditional approaches of creating value through things, but not Internet of Things. Therefore, I investigated how companies create value through IoT development. I conducted 6 case studies, including IoT system for healthcare, home security and energy, terrain maintenance, and 3 subsectors in farming industry, such as vertical farming, tropical farming, and dairy farming. So this is generic process of traditional product development, which consists of 6 phases. Activities are around hardware only, and this is new product development process for Internet of Things. The phases are kind of similar, but IoT process has to consider hardware, software, and data algorithms development activities all together. So based on these activities, I have developed new process model for IoT development, reflecting the attributes of complex IoT development practice. It consists of 3 cycles, which is different value creation trajectories, I would say. The process starts from the top left circle, which is hardware-centered. Then once the system is deployed, it moves to either software-centered development at the bottom or machine learning algorithms centered development on the right, or back to hardware-centered development. And this is distinctive to existing process as it's continuous and emergent. It encompasses each element, hardware, software, and algorithms, illustrated with a different color legend, like hardware is green, software is blue, and the data or algorithm development is a pink color. they are all like used as a design resource, but because development speed and approaches are distinctive to each other, IoT development is very complicated. Like hardware development takes for ages to launch the product, whereas software can be developed and launched overnight. Algorithms, as considered as software, the development doesn't take that long, but collecting, cleansing the data for use to use for algorithms takes very long time. So how this model could explain three approaches to IoT value creation. These are the different trajectories of IoT value creation that the companies took. These approaches are not mutually exclusive, but can be applied at the same time. I'll go through each approach in the next slides. So this is none of the three approaches because it didn't aim to commercialize the system. So the trajectory of the value creation stopped after the test deployment. It is because this is like 100% EPSR's funded project only for the research that aims to explore the cost and value of data collected from healthcare IoT system. And this is the first approach to IoT value creation and commonly observed if you are just launched your IoT system. Like two cases, vertical farming and tropical farming IoT development, follow this trajectory through which the companies successfully released their system, then they focus on scaling up the number of IoT deployment and releasing software update and like correct their system. Whilst scaling up, they can collect more data and increase the accuracy of the system in machine learning. Their aspirations were to develop more products interconnected to current system, like systems of systems, or create value through trading the data they collected, but it did not happen yet when I spoke to them. This is the second approach to IoT value creation, which focuses on developing system of systems through connecting multiple devices and applications after the launch of their first IoT system. So the process is mainly around hardware and software-centered development. Two cases demonstrated that they create value through this approach: home security and energy IoT system and drainage maintenance IoT system. So the first company started, the home energy and security company, started developing the home security and safety with multiple devices and applications, including doorbell, key fobs. Then they launched energy IoT system, including smart plug and energy hub. They continuously co-create value with other companies in technology development or software platform, including Google, Yahoo, like telecom companies, gas companies, whilst adding new products and services. While maintaining the system and monitoring data, the company has to ensure data security, privacy, and ethics because they collect very private data. The second company originally supplied two-way radio rental systems for 35 years, then brought up IoT solutions to a GUI management solution in highways. Once the solution demonstrated its economic value, they developed similar system for the rail sector, not highways. During the process, they had constant conversations with stakeholders because all the stakeholders' interest varies, and also the product service specification had to be agreed. It was continuous back and forth interaction of the development process they described. And another challenge they had was building trust with the end users, the GUI cleaners. When the company introduced the system, they believed that the IoT system is harmful, like monitoring their work, so they intentionally put wrong information. So the company had to put enormous effort to convince that the system does not do any harm to them, but reduce their workload. So last approach to IoT value creation was to deliver new service through embedding new algorithms. So as you see, the value creation trajectory is more to do with top right and bottom, which is algorithms and software centered. This IoT system consists of a smart collar, the base station on the farm application and web service. Each cow wears a smart collar, which monitors heat expression, and using machine learning algorithms, the farmers will inform the predictions of when the cow is on the fertility period so that the productivity can be increased. Whilst it's being deployed, they identified another user need, which is to identify sickness and determine required response or treatment earlier than through observation. In solution ideation stage, the team discovered that they could add health management features through embedding new algorithms without any change of hardware or collecting more data. These are 3 approaches, and through the case studies, I have also identified 5 key design principles in IoT development. First, IoT must be co-created. It is because developing system of systems requires different components, elements, skill sets, and experts in different fields. Therefore, value co-creation is must in IoT development. Second principle is that the IoT system must design user-centered. I know this is like fundamental in every human-made object, but it is more highlighted in IoT development as it has to bridge the gap between users and IoT technologies. And continuous emergent value creation is also important as it is related to your long-term business model. Responsible innovation is highlighted a lot from the companies that you have to consider the ethics, all these issues from the set of your business. Otherwise, you will face critical issues in trust and security. And last but not least, data as a design material. Data-driven design for innovative product and service was stressed by companies. Speaking of data-driven design, I would like to introduce you data-driven design framework that I've developed for last year, which is demonstrating how data is used within new product and service development process. This is published in conference paper and then going to be published in journal paper as well. So from the research, I have identified 7 design activities, which is validating decisions, planning business strategies, and product service portfolios, discovering context and user issues, defining the feature specifications, generating concept ideas, customizing products, services, and maintaining the system. And due to the limited time, I wouldn't go through all the details, but happy to share these if you would like to know more about. And what I'd like to say is, if any of you would like to create value using data you have, please keep in touch with me. In DigiLab project, we are currently looking for companies who would like to use data for products and service development. For instance, we are working with an IoT company that develops and deploys bike sensor, like in many cities globally. They have been collecting massive data set and demonstrated the value of it, but there is an obstacle to actually realize the value through a tangible outcome. So we are planning a series of service design workshops with the internal and external stakeholders to develop the solutions. Even though it's not about like data-driven design, please contact me about like IoT development. I want to know more about your process. Thank you so much. That's it.
Any questions for Dr. Lee? There's got to be some questions. Go on.
Hi, really liked your really loved your diagrams with the 3 circles kind of interlocked, overlocking, trefoil maybe. Could you just say how you developed that?
Yes, so I interviewed the companies, listened how the journey of their IoT development, like for 6 companies, 6 projects, and then they also did illustrate their journey as a phases, and then I accumulate them, and then I analyze the keywords of each phases. So you can't really see here, but this is first phase, second phase, third phase, fourth phase, and this is for hardware development for first phase, software and data. I mean, data, there is not much activities in the first phase, but it starts from second phase. So, but then I identified the 3 trajectories from the interviews. So that was how I could create these like 3, continuous cycles of development.
One last question, or time opportunity for one last question. If anybody's got a burning question, go on, Albrecht.
Hello, I'm Albrecht Kotzer. You are from a university. I'm also from a university. I suppose you also teach. Have you integrated all these approaches already to your teaching to get all the new ideas and the new approaches in your students' heads?
So I don't teach students at the moment. That's
a pity.
researcher. Sorry.
That's a pity.
That's yeah. That's so. But I just started my postdoc position. 1 year ago. So I'm kind of like collecting my teaching materials to teach students, and I'm like sometimes give a guest lecture to different universities and so on. But of course, I use those contents for teaching. Thank you.
I'm sure you'll get to chat about that. So amazing. Thank you so much.
Thank you.